We continue our analysis of functions by taking a look at even and odd functions. Now, I believe I mentioned this earlier, and at least in a video, and in relationship to the types of symmetries we have. So actually, even functions and odd functions have a special kind of symmetry to each one of them. And it's interesting to know those aspects of it. If you can recognize when a function is even or odd, then that gives you some interesting information that can prove to be useful in other ways. But there's a way to determine this, not just by looking at the graph, but also through the algebra. And so this is a little bit of analysis of functions that we're getting into. So I'm going to start off by giving you an example of an even function. And this one is going to be y equals to f of x is x to the fourth minus 9x squared. All right, now you don't normally write y equals f of x, but I just want to emphasize that y and f of x are interchangeable when it comes to graphs and algebra. That f of x is just another way of writing the y variable. Well, the graph is going to look like this. You would just have to take my word for it, I'm afraid. But we will analyze these types of polynomial graphs in a later chapter. And so anyway, this one has three intercept points at 0, at -3, and at +3. And so it comes down like this, and I'll do it in red. Comes down from the top, goes to the intercept, bottoms out somewhere, and then comes up and just touches the origin, comes back down, bottoms out, and comes back through again. Alright, so it's not a perfectly drawn graph, but that's pretty hard to do by hand. But the right half and left half, if this was drawn perfectly, would look identical. And in fact, if you took the right half and just flipped it over to the left half, or vice versa, you would get the other side. And so this is called a reflection. And what are we reflecting across? It's across the y-axis. So let me write the qualitative aspect of an even function. Let's see. Even functions are symmetric to the y-axis. Okay, so that's what an even function is. It's symmetric to the y-axis. Now I want you to follow me on this, on how can we analyze this algebraically without looking at the graph. And it comes from looking at some features here. For one thing, notice that f of 3 and f of -3 both give me the 0 for y. They both land on the x-axis. So f of 3 and f of -3 both equal to 0. And let's look at some other points. How about f at 1? All right, we should be able to calculate that pretty well. And -1. Well, f at 1, and it turns out it equals to f of -1. What would they be? If I put 1 in here, I get 1 minus 9 is -8. But if you put -1 up here, -1 to the 4th power is +1. -1 squared is +1. In other words, the negative part of the number cancels out because we're raising that number to an even power. And so f at 1 and f at -1 equals -8. And let's see that on the graph. If I travel down from 1, I get presumably -8. If I travel down from -1, I should get -8 there as well. So if this was drawn perfectly, it would look right. It's close, but anyway, that's that. Now you can plug in 2 and -2. If I plug in 2, I get 16 minus 36 is -20. If I plug in -2, I should get the same result. So here's what we're going to see, is that whenever you travel to one side of the graph and plug that x value in, no matter where you go, if you travel to the opposite side of the graph, the same distance, and plug that number in, you get the same y value. Now, what does that mean in terms of the algebra? It means that f of negative x equals to f of positive x. So let's check that up here just for good measure. So I'm going to plug in minus x into this function, which means I'm going to replace the x's I see with my negative x input. So that gives me negative x in parentheses to the fourth power minus 9 times negative x squared. And this comes out to what? The negative is going to cancel because of the even power. So I get x to the fourth power. And here I get x squared minus 9 times that, so minus 9x squared. Well, that's the same as the original function. So this equals to f of x, just as it was supposed to. So this is the property that always works with even functions. So it's a way of testing to see if a function is even, is to test to see that when you change the sign of an input, you get the same result, the same output. And in other words, f of negative x equals f of positive x. All right, now let me give you another example of an even function.